Good morning or good afternoon, depends on where you are listening from. First of all, I would like to thank the conference committee to give us the chance to speak about our research. Our research is about Bangla handwritten digit recognition using pre trained models. In today's presentation, we will talk about the background of our research, and then I will speak about the problem statements, what we tried to solve, and then later we'll talk about the aims and objectives, what we have achieved. After that, I will talk about the research methodology and research design. We will also speak about the experiments we have done and the results we got, and from there onwards we'll talk about the contribution and the future work what we have proposed. So let's get started. According to the ethnologue, Bengali represents 4% of the world's population, so approximately 265 million speakers around the world, around the globe, speaking Bengali. Despite this huge number of Bengali speakers, very little research has been done to identify or recognize Bangla handwritten digits for different applications. The application could be to identify postal code digit recognition, to license plate recognition, from checks in banking system to the exam paper registration number recognition. Now the question is, what is the problem to create an effective recognition system? Let us identify the problem one by one. The picture we can see at the right hand side will give you an idea what it is. I will explain you later, but before that I wanted to explain why the Bengali digit recognition is a complex way to identify and recognize, because of the shapes, the size, and the writing styles, and because everyone's handwriting style is not the same. Secondly, the nature of the writing, like curvatures of the writing styles, are different. It's not like English or German, like straightforward writing. It's a little complex writing style. Thirdly, if you see the number at the right top corner, you will see the first one represents 1 and the second one represents 2, but by the normal eye you even cannot identify which is what. Just the small striking similarity gives the total change of the numbers. So this is also making the problem for any kinds of machine learning algorithms, machine learning methodologies, to identify the digits properly. I would like to draw your attention to this part of this image. This 8 is actually, you can see it's not similar, it's totally unidentical, but just because of a striking similarity, this same number looks totally different. I would like to take your attention to this number as well here. So this both number are 4 in Bangla, which looks like 8 in English. This one looks 4, which is in Bengali, but this one looks totally different than the 4, just because of a small little change on it. This is number 5 and this is number 9, but looks very similar just because of these are two different numbers, but small little striking similarity is changing the whole concept of the number. And this is one of the reason why different researchers, despite working hard on figuring out or recognizing the numbers, they couldn't come up with the better accuracy using supervised machine learning algorithms until today. So what was our aim? Our aim was to develop a better digit recognition model that is able to identify Bengali handwritten digits with increased amount of accuracy and efficiency. To achieve our aim, what we have done, we have experimented different pre-trained model on Bangla handwritten digit datasets. We have analyzed the performance of different models, how they have done in terms of their accuracy, in terms of IDUC curves and different matrices, evaluated the results to choose the best models. So before we go in depth with our results, I just wanted to show the methodology we have chosen to identify and work throughout the research. So if we look at this research methodology, you will see we have done pre-processing twice. One, just after the data collection, we had to figure out if there is any kinds of missing data or any of the data needs to be annotated or probably separated from the main data set. Then we divide the data set into two parts. One is training data set and second part is testing data set. We kept the testing data set for the evaluation of the final model. Then we come up towards the training data set, where before putting the data set into the training of the model, we try to pre-process again, figuring out if we need to do any kinds of feature scaling or resizing or probably feature extraction as well. Then later we send those data set towards training the model using different machine learning models and a pre-trained model like ResNet, EfficientNet or CNN. At the same time, we also try to figure out how we can make that model more efficient and better in terms of its accuracy. So we try to hyperparameter tune or probably tune the models a little bit. Then we iterate the process to find out the best and optimum model, and then at the final stage we then evaluate our model to check if our model is doing best by testing or evaluating the test data set. Later, after getting the results, we use the same model on the new data set. And from here onward, I would like to ask my colleague Musarat Nipun to continue the presentation from here, and thank you very much from my side.
Thank you, Rizwan, for giving me the opportunity to discuss results and analysis. We consider three benchmarking parameters: precision, recall, and F1 score, to calculate accuracy, macro average, and micro average. However, we emphasize on macro average values while taking decision, as macro average is a straightforward approach for averaging numeric data that treats all classes in the same way without taking the supporting value into consideration. In the graphs, the result of the trained dataset are illustrated by the blue line in both images, whereas the results of the test data are shown by the red or orange line. From three of the graphs, we can see that the loss rate was lower and the accuracy rate was higher in test data after training the trained dataset. Moreover, the difference between the loss from 1 epoch to 20 epochs was higher in the training dataset, but this difference reduces after training the data, and test data showed fewer differences across the epochs. The same results were found in the accuracy graph as well. From this, it can be mentioned that if the models can be trained properly, the models will provide more accurate results in test data. Then we compared the results for three of the dataset. From the above table, you can see that EfficientNet B0 has the capacity to act better on training and is able to provide more accuracy compared to the other two models. It also proves that with proper training, this model performs best recognition, and the accuracy for all the epochs within a test dataset is close to each other, which means it provided almost the same accuracy while recognizing the Bangla digit from 0 to 9. Also, from the comparison graph, we can see that both EfficientNet B0 and ResNet 50 have a higher accuracy rate than the exception V3 model. EfficientNet B0 has the highest accuracy, 0.96, compared to all three models. So in conclusion, it can be settled that EfficientNet B0 pre-trained model worked the best rather than the other two models. So the main contribution of our research includes proposing the most efficient pre-trained CNN model for recognizing Bengali digits, identifying the pre-trained model which is able to provide the highest accuracy while recognizing different Bengali digit images, identifying which pre-trained model can be trained more efficiently. So our research implemented a single dataset and three pre-trained CNN models to recognize Bangla digits and determine which model offers the maximum accuracy. In the future, we have planned to examine the performance of these pre-trained models when working with several other datasets. In addition, we will evaluate the precision of all pre-trained CNN models not specified in this study, such as VGG19. These future studies will increase the opportunities for future researchers and academics to utilize CNN models. And here the list of the sources. Thank you very much for giving us the opportunity to speak on our research.